Okay, so let's come to the system integration architecture. Um, if we consider the system architecture, if you look at the picture, so it says from the mobile front end, what we have is we have different options. The option number one is to choose a movie name and then get the movie details from different APIs in both from both the APIs, and then according to that, what technically what it does is the mobile front end takes the movie name and it sends the movie name to two different APIs, OMDB and NY Times, and from OMDB API it will get the movie details and it will show to the front end. So this is one part. The other part of the architecture is that from the movie name, it will take the movie name and send it to the NY Times API, and from NY Times API, it will get the corresponding reviews, and all the reviews are sent back to the sentiment analytics engine. And from sentiment analytics engine, what we do is we get the sentiment, and this sentiment is shown on the front end mobile app. So this is how the system, the entire system or the full stack application is functioning. So the technologies which we have used so far in this thing, entire app is the Cordova. Using Cordova, we have designed the entire application, so it can actually be used as an to deploy this thing in the app in iOS or in an Android mobile. So I've mostly tested and done in iOS, and my other team member he tested it in Android. It should work in both. So for it should also function with the browser, but for better performance we would suggest to be built and run in a mobile app. So since we made the things responsive, it shouldn't be a problem though. But again, yeah, for better view, because Chart.js seems to be functioning very good with the app. So for the backend, the analytics engine is entirely developed in Java. So even in I mean the core algorithm is written in Java, and yeah, so the other technologies like Ajax. So Ajax calls just to if you look at the app, what it does is it doesn't load the entire page. What it does is it just loads that particular area of the app where we are expecting the results. For example, the sentiment, the graph which we are about to show it on the mobile app. So that is taken care by Ajax. And then ngrok. Ngrok is used for tunneling. For example, I was working on the back end, and another team member was working on the front end. So for both of us to work on at the same time and to be able to use both front end and the back end, we need to expose our ports so that he can connect to my laptop and I should be able to access his front end. So we use this ngrok tunneling service, which technically opens my port for him and his port for me, so that we both can interact with each other with whatever the ports we have exposed. For example, I was running the server on 8080 and he was accessing my server response from 8080 and the URL which I sent. So this URL is also present inside the app which we have used. Showed it on the demo too. So yeah, that's one thing. The other part is the chat.js. So in chat.js, what we did was, if you see the sentiment label on the front end, we could have shown in any other approach. For example, just we could have shown some text that it is positive sentiment or negative sentiment or neutral or something. But instead, we chose to show some graphical representation. For that, we used chat.js, which showed the donut pie chart onto the mobile app, which has yellow and red labels on them, showing the both positive and negative labels. So yeah, the other HTML, CSS, and JavaScript was used to write the Ajax call, API calls, and styling is done in plain CSS, and the basic HTML to show input and submit and other buttons on it. And the entire backend engine was evaluated, and the ground rules were evaluated in Weka to understand the performance of the entire approach. So we had actually wrote another function which takes care of number of text files, and then um, evaluates the performance and shows the number of things which has correctly guessed or correctly produced as the good correct sentiment as expected. So there are like plenty of challenges that we have faced in this project. So some of it was starting in the challenges started initially from the dataset. So there are a couple of options for us to choose in the dataset. And we chose this particular data set because it's the regular usage. Like we whenever we generally go for a movie, what we do is we generally check IMDb or some review of some big newspaper, let's say New York Times. So that's one thing. That's why we have chosen up with the movie data set, so that it gives a good amount of estimation for us to understand whether the sentiment we are expecting it to be correct or not. For example, if we choose any financial data, all four team members may not be really comfortable with understanding the sentiment of a particular paragraph in finance from the finance data. So that's why we chose movies, so that each and every one of us can understand it better and then program accordingly. That's one part. And the second part is the choosing the technologies. Initially we were actually started off with doing a website, but every one of us felt website is normal, and then we wanted to do something different, and we started off getting an idea of using the same approach to design a mobile application. Because if you look at the entire application, it just shows the sentiment. We need to get the sentiment. So whatever the functioning is from the back end, so technically we have a sentiment that is to be shown. So if you have a mobile application, that would be concise and clear for us to understand the functioning of the project. So then of course, while using the mobile, creating the mobile app, we could have gone for a native mobile application, but again, every one of us were not really good at one particular each specific. For example, let's say Swift, uh, all three of us were not really good at Swift. So if there is any problem, we did not have any, we probably would have spent so much time wasting on other things rather than working on the core concept or creating the algorithm here. So that's why we chose Cordova, so that we can it's easy to code and understand the entire concepts. And for the system design, yeah, there are a couple of things which we initially started. For example, initially we have started off, okay, let's do one thing, let's create movies, let's get details from the movies and then show it in the front end. So that system design was okay, but it was not clear enough. For example, what we are doing initially in is to, for example, 3 4 different critics would have written 3 4 different reviews. What we have done technically is append all the different reviews into one big review, and make that one big review to be passed to the analytics engine to get the sentiment. Yeah, according to the, why we have done that is pretty basic. Because we don't want to have each review showing positive or negative. Because ultimately the user has to understand, okay, so now tell me what is it. So is it the movie is good, the movie is bad, the movies has a negative sentiment, or the movie review has a positive sentiment. He has to know the ultimate sentiment. So that's why we have chose to append all the reviews we have obtained from each dataset. That's one part. And the another challenge we have faced was with the connections. Because yeah, of course, I was working on the front end, somebody was working on the back end, so we were unable to connect. The major error was the course error, cross origin resource policy error, where we were unable to get, the back end was able to send it, but the front end was unable to receive it because of either the web browser issue, or we were unable to connect the right ports. So those were also some issues we faced in the beginning. So we ultimately got through that by using the tunneling service and Grok, or we could have used other things like local tunnel or something like that. So the other thing which we have done is the troubleshooting. So the major challenge was the troubleshooting, where we have to understand what exactly was going wrong. For example, sometimes the label was showing negative. So, or sometimes even the you may not know, even the label right now which is showing correct, maybe because of the overfitting. So that overfitting and all those things have to be taken care of. So one part was to either get a better performance from the backend system. The other thing, most of the things which we faced initially were making at the front end, because we don't know how to exactly show things graphically towards the front end. So we have to learn other technologies like Chart.js, or making that spinner work on the front end. The user should be able to understand, okay, so something is working on the back end. So he should understand, okay, so I have not received the sentiment yet. So he should wait, so that, so for that, for him to understand that he should wait. So we need to add a spinner, so which we have faced difficulty in the beginning. Yeah, and the final part and the best part is about the engine efficiency. We even now don't feel that we are satisfied with the efficiency of the engine, because yeah, it may be possible that overfitting of the data is um, possible in this case, because it's just like thousand and thousand text documents we have given for the training data set. But this can be used for the future scope of the project to improve the efficiency of the project. For example, so let's say in the future work, how can we handle this thing? So to improve the efficiency of the engine, one part we have actually started working on it. That thing is called the feature extraction. What we are doing basically is we are actually giving different weights to each features. We technically extract the features or votes from each positive and negative labels, and then give some kind of weights to them, and then save only those features that are existent before. So if there is a certain feature that is not existent, we don't take care about, I mean, we don't really care about those particular feature. um, and once we are done with the feature extraction, what we do is we use some kind of threshold. For example, in this case, using the statistically proven method called chi-square, what we technically do is use this chi-square as a threshold, and then depending on this threshold, we basically use the feature extraction model, so that only those particular features which cross this threshold are used in the um, engine and at the back end. Yeah, the other improvement which can be done in this process is the database storage and connectivity. We could have actually stored this entire data in, let's say, a MongoDB, any NoSQL um, database, document database like MongoDB. Why is because all the data which we are talking about is about comments and reviews. So all these are like user defined and unstructured data, which maybe, for example, in the future we may be talking about comments or people tweets about a particular movie from the Twitter. So in that particular scenario, we need to store these things. Right right now it works, but once the scale is huge, we may need to shift this thing and store that thing in a database. So to store the data in a database, so in that particular scenario we may probably choose a MongoDB or some NoSQL database. We wanted to do it, but since time constraint, we couldn't complete it in terms of database. So yeah, the faster data rendering for now, if you understand, if you see the picture of entire this app functioning, it takes a lot of time to render things on the front end. So for that, we are trying to improve the efficiency so that it takes less time. So another part of improvement would be web crawler. So instead of getting the data from APIs and stuff, or getting the reviews and then sending it to getting the reviews from, so let's say New York Times API, what we want to do is we want to get the data from yeah, for now it's just IMDb or NY Times, so two three resources. But in future we may be talking about 10 different websites, or anything that is existent on web. We want to crawl them and then crawl those pages to understand this data, and then send it to the backend and then get the required information. The final efficient result of this particular app would be a recommendation system, where a user, I mean, where we should, right now we are just telling the user whether the movie's review is good or bad, or is, I mean, is it positive or a negative. Depending on that, he can choose whether to watch a movie or not. But later what we would suggest is we want to tell him some recommendations. For example, if he's really interested in action, so all the movies should be, in terms of action, should be provided to him. Or let's say if we have a rating system where, for example, a child should be able to see, so we should be able to label that particular movie as a PG-13 or PG-18, according to the rating standards. So that okay, there's a lot of violence in it, there's not much violence in it, or something similar to those things. So finally we can conclude that the approach which we have used is the naive based approach for this entire full stack mobile application, which does data in the backend, and which does data analytics in the backend, and it analyzes a particular review, which a review of the plot, we send it to the backend and analyze and send us a sentiment, and which whose results are shown on the front end using Chart.js. Yeah, so we're actually, in addition to that, a user can enter a particular review, and then it analyzes whether the review entered is a positive or a negative label or not. Yeah, these are all the references that we have done. So I guess